Have you ever thought about what goes into a real scientific experiment? Most of us get to do science investigations when we're young. School experiments are easy and fun, but what about real scientists like chemists, physicists, and medical researchers? What kind of work do they have to do? How do they go about designing their experiments in the laboratory? Experiments, remember, are one of the key components of the scientific method, which is a set of procedures that scientists follow to gain knowledge about the world. Other components of the scientific method are questions, hypotheses, observations, analyses, and conclusions. While experiments are only one part of a scientific investigation, they end up being accountable to the other elements. In this lesson, we'll see what goes into making a valuable experiment and learn how scientists design useful investigations. A scientific experiment is an ordered investigation that attempts to prove or disprove a hypothesis. So its primary purpose is to test whether someone's prediction is correct. In designing experiments, scientists have to answer some pretty complicated questions, like, does my experiment answer the question I'm trying to solve? Does it adequately test my hypothesis? Can I make observations about the results of my experiment, and will I be able to analyze those results? Finally, if I run this test, will it allow me to come up with some kind of conclusion? Scientific experiments are different from other kinds of tests because they are required to fit in with the scientific method. Another important factor is peer review by the science community. A scientist's work isn't generally recognized unless he follows the standards set by other scientists around the world. A few basic rules apply to the design of a good experiment. Let's take a look at what a science experiment needs. Rule number 1. The experiment must show that a hypothesis is either supported or not supported. In science, we try to avoid using terms like right and wrong, and we don't say that hypotheses are proven or disproven until we're really sure about it. A single experiment is not enough to prove anything with 100% certainty. The second rule is that the results of an experiment must be measurable and objective. Scientists use standard units to measure different properties like length, time, volume, mass, and speed. Sometimes we need special equipment to observe things in a measurable way. For example, we can't see ultraviolet light or hear infrasonic sounds. We need special devices to detect and measure those properties for us. The third rule for scientific investigations is that the experiment must be repeatable by other scientists. Peer reviewers want to make sure that other scientists can run the same experiment and get similar results. This is one of the reasons we standardize our measuring tools and equipment. Scientists must be able to read anyone else's report, follow the steps exactly the same way, and compare their findings to the original test. In science, new ideas aren't taken seriously until many scientists have tested them many times. So it's important that scientists share their techniques and confirm each other's findings. So, how do scientific ideas become part of the community knowledge base? If everyone's always double-checking each other's work, how do hypotheses become theories? How do theories become scientific law? Well, first of all, keep in mind that theory in the world of science is not the same thing as a theory in everyday language. I might have a theory that my friend Jackie is going to ask her classmate Jimmy on a date, but that's not the same as a scientific theory. In science, a theory is a statement that is generally accepted as a summary for a hypothesis or a group of hypotheses. You can also call a theory an accepted hypothesis. When one hypothesis has been tested by many different scientists, and most of them have come to the same basic conclusion, then we can start calling the hypothesis a theory. There isn't any grand master of science who makes the final decree about a theory. It's more like a general consensus. And a theory can still be disproven if further research reveals enough evidence to refute it. A law is different from a theory in that it is viewed as a universal fact. A scientific law is a general statement about a group of observations which has no exceptions to the rule. Most laws can be stated as mathematical equations, like Boyle's law and Pascal's law. Laws in biology are statements about how living things